Hi again, everybody. Today the open-ended that we're looking at is going to involve linear equalities and maybe a little bit of common sense, but we'll get to that in just a second. So Zeke is going to solve the inequality shown below. In the inequality, W represents the width of a rectangle. Please keep that in mind. That is going to be important. Okay? So first of all, it says solve the inequality. So to solve this inequality, it's an absolute value inequality, which means that we're going to have two separate inequalities to solve this. So, so it's the absolute value of 4W minus 3, close absolute value, is greater than or equal to 8. Okay? Sorry about that. A little technical difficulties there. When you have an absolute value like this, you have to split up into two separate inequalities. So we're just going to say that 4W minus 3 is greater than or equal to 8. Now, since it's greater than or equal to, we're also going to use the OR. Okay? And now, the other equation, you flip the sign and flip the inequality. So 4W minus 3 is less than or equal to negative 8. Because if we can make it less than negative 8, let's say we can make it negative 10. The absolute value of negative 10 is 10, which is bigger than or equal to 8. So that's why you have to include things both above 8 and below negative 8. So we solve this. We add 3 to both sides. 4W is greater than or equal to 11. We divide by 4. And W is greater than or equal to, we can leave it as 11 over 4. We can make this 2 and 3/4. You could really even make it 2.75. Okay? The other one here is 4W minus 3 is less than or equal to negative 8. We're going to add 3 to both sides. And 4W is less than or equal to negative 5. We're going to divide by 4. And we're going to say that W is less than or equal to negative 5 over 4. Remember that this is an OR question. So either one of those things would have to be true. One or the other, not both. So we come back here, and it says in part B, graph the solution to the inequality on a number line. So let's do that here. We can put this here. For part B, here's 0, 1, 2, 3. Notice that I use integers, negative 1, negative 2, negative 3. I use integers because part of what they're testing you on is the ability for you to pick out where 2 and 3/4 is, and where negative 5/4, which is negative 1 and 1/4 is. So 2 and 3/4, 2 and 3/4 is 3/4 of the way between 2 and 3. This is greater than or equal to, so we're going to have a solid dot there, and we are going to go to the right. I made that a little bit bolder than what I had to, maybe, just so you can see it. The other one is negative 1 and 1/4, so we fill that in. Okay, again, maybe a little bit bolder than what it needed to be, and we go to the left. And that's what your line should look like, your graph should look like for part B. For part C, the question is, Zeke does the work and claims the answer is negative 3. Is this a reasonable solution to the inequality? Explain why Zeke may think it is, but why he is incorrect. Well, if you come back here, negative 3 certainly looks like it should be a solution. It's less than negative 1 1/4 or negative 5/4, whatever you use. So it certainly seems like that should be a correct answer. But if you remember right, the first thing that we said for W was that it represents the width of a rectangle. If W represents the width of a rectangle, then negative 3 doesn't make sense. You can't have a rectangle that's negative 3 inches or feet wide. Okay? So the answer to part C here is that since W represents the width of a rectangle, it cannot be negative. Therefore, negative 3 does not make sense as a solution. I hope this helps you with the next open-ended. And as always, I hope you have a good rest of your day.